what's the shape of the orbits in our solar system? If you're thinking of a circle, then you're wrong. It's actually an unfamiliar shape, what we called ellipse. In this video, we'll be showing you ways on how to solve this type of conic sections.
An ellipse is one of the conic sections that most students have not encountered formally before, unlike circles and parabolas. Its shape is like a rounded curve which looks like a flattened circle. For better understanding, let's have these examples.
And now, let's talk about the parts of an ellipse. First, we have the center. And next, the foci are F1 and F2, as the C units away from the center. Vertices are V1 and V2 are points collinear with the center and the foci. If y is equals to 0, then x is equals to positive and negative a. Each vertex is a units away from the center. The segments V1 and V2 is called the major axis. Its length is 2a. It's divided in ellipse in two congruent parts, meaning they are the same. Co-vertices or CV1 and CV2 is the minor axis. Each co-vertices has b units away from the center. The minor axis and the CV1 and CV2 is a 2b unit long. Since a is greater than b, the major axis is greater than the minor axis.
To sum all of this information up,
Let us have the ellipsis equation. X squared over b squared plus y squared over a squared equals 1 is for a horizontal ellipse.
x squared over a squared plus y squared over b squared is equal to 1 is for vertical ellipse.
However, you have to remember this is only applicable if and only if the center is at the origin. For ellipse whose center is not at the origin or at the HK, these are the equations. X minus h squared over a squared plus y minus k squared over b squared equals 1 is for vertical ellipse. And x minus h squared over b squared plus y minus k squared over a squared equals 1 is for horizontal ellipse.
Example number 1. X squared over 25 plus y squared over 9 is equals to 1. For us to sketch the graph, let us first find the value of a, b, and c. Since 25 is the biggest number, then a squared is equals to 25. To find the value of a, let us find the square root of 25. Then the value of a is equals to 5. Second, b squared is equals to 9. To find the value of b squared or b, let us find the square root of 9. Then, the value of b is equals to 3. Lastly, to solve for the c, let us apply the modified Pythagorean theorem.
C is equals to square root of a squared minus b squared. Let us substitute the value. C is equals to,
Since a squared is 25, then b squared is equals to 9. Then 25 minus 9 is equals to 16. To find the value of c, let us get the square root of 16. Therefore, the value of c is equals to 4.
Apparently, this equation is an ellipse whose center at the origin point. Since a squared is under the x variable, this is a horizontal graph, meaning that we can locate the vertices and foci at the x-axis. Since a is equals to 5, we have to move 5 units left and right. 1, 2, 3, 4, 5. Vertex 1 is at negative 5, 0. 1, 2, 3, 4, 5. Vertex 2 is at 5, 0. we can see that C is equals to 4. We have to move 4 units to the left and right. 1, 2, 3, 4. Focus 1 is at 4, negative 4, 0. 1, 2, 3, 4. Focus 2 is at 4, 0. Since B is equals to 3, we have to move 3 units up and down. 1, 2, 3. Co-vertex 1 is at 0, negative 3. 1, 2, 3. Co-vertex 2 is at 0, 3. After finding all of those points, we can connect them. And make this ellipse.
Example number 2. 9x squared plus 16y squared minus 126x plus 64y equals 71. This problem is in general form, so we have to transform it into standard form. First, let us combine like terms. 9x squared and negative 126x are the like terms, and 16y squared and 64y are on the other side. Now, 9x squared plus minus 126x plus 16y squared plus 64y Afterwards, let us divide this term and this term by the coefficients of x squared and y squared. Copy 9. 9 divided by 9 is 1, so we have just to bring down x squared. Negative 126x divided by 9 is negative 14x. 16y squared divided by 16 is y squared. So first we have to copy the 16 and then the y squared. 64y divided by 16 is 4. Then bring down 71. The next step is to transform this into a perfect square trinomial. Now you have to remember that every time you would add here, you should also add on the other side. So we have to put blank and another blank. Okay. The next step to get the third term in each term. So to get the third term, we have to use b over 2 squared. In this term, the b is negative 14. So, negative 14 divided by 2 is negative 7. Negative 7 squared is equals to 49. Since we added 49 here, we also have to add 49 here, multiplied to 9. And for this term, the b is 4. 4 divided by 2 is 2. And 2 squared is 4. Again, since we added 4 here, we had to also add 4 on the other side, multiplied by 16. Deposa. Now let's move on with simplifying. We have to copy this.
Copy 71. 9 times 49 is 441. And 16 times 4 is 64. Okay. So 71 plus 441 plus 64 is equals to 576. So we can just in this part, let us proceed with transforming this and this into perfect square binomial. Copy 9. Square root of x squared is x. Copy the sign of the middle term, negative, and the square root of the last term, 49, which is 7. Plus, bring down 16. Square root of y squared is y. Copy the sign of the middle term, plus, and the square root of the last term, 4, which is 2. Copy the 576. Now, if you have remembered, the standard equation of an ellipse should be equal to 1. So, for this side to be equal to 1, we have to divide this to 576. And since we divided this side into 576, we also have to do the same in this side. So, 9 divided by 576 is equals to 64. Then copy x minus 7 squared plus divided by 576 is equals to 36. So copy the y plus 2 squared. Lastly, 576 divided by 576 is 1. We can now proceed in finding the A, B, and C.
Let's solve for the A, B, and C. First, for A, since 64 is the biggest number, then 64 is equal to A squared. To find the A, let's find the square root of 64. A squared is equal to 64. Square root of A squared is A. Square root of 64 is 8. And for B, B squared is equal to 36. Square root of B squared is B. Square root of 36 is 6. For C, use the modified 500. C is equal to A squared minus B squared. C is equal to 64 minus 36. 64 minus 36 is equal to C is equal to square root of negative of 5.
After finding all of those distances, you can now find coordinates. Locate the center at 7 and negative 2, then proceed in finding the vertex. Since the larger number is located under the x variable, this is our horizontal ellipse, meaning that our vertex and focus lie in the x-axis. This also means that we will be moving right and left behind them. Now to locate the vertex, let us move 8 units to the left. That makes it 7 minus 8 equals -1. So we have here our vertex 1, which is -1 and -2. And we have also here to move 8 units to the right, which makes 7 plus 8 equals 15. We have here our vertex 2, which is 15 and -2. Now for the focus, let us locate square root of -8 to the left, which makes it 7 minus -28 equals 7 minus -28 and -2. And now for the right, let us also move square root of 28 units, which makes it 7 plus 8 square root of 28 and -2. Now for the co-vertices, let us move move 6 units down. So we have here negative 2 minus 6 is equals to negative 8. So we have here our properties 2, which is 7 and negative 8. After locating all these points, you can now finally connect them and make this ellipse.
Example number 3. We have this equation of ellipse in a general form. And what we're going to do is that we're going to transform it into a standard form. To transform it into a standard form, the first thing that we do is that we're going to combine the like terms. As you can see, the like terms here are and 32x. Copy the sign. Plus, we have the 4y squared. Copy the sign. And what we're going to do with 32 is that we're going to transform it so it will be equal to 32. After that is that we're going to factor this out. So, we're going to divide by itself. So, 16x squared divided by 16 is equal to x squared. Copy the sign. We're going to divide it as well on the other side. 32x divided by 16 is equal to 2x. Copy the sign. And so what's here? 4y squared divided by 4 is equal to y squared. Copy the sign. 16y divided by 4 is equal to 4y. The next step is that we are going to make it a perfect square binomial. And we have this formula. The b over 2 squared. Our x here is 2, so we 2 over 2 squared. 2 divided by 2 is equal to 1. Then 1 raised to 2 is equal to 1 the square root of 1 is 1. For the y, we have the 4. So, 4 over 2. 4 divided by 2 is equal to 2 raised to 2 is equal to 4. So since we already have the last term, what we're going to do is that we're going to fill up blanks. We have 1 and we have 4. And we're going to multiply this term with this. So 16 times 1 is 16. And 4 times 4 is equal to 16. Next, we're going to make a perfect square binomial. 16 square root of x squared is equal to x. Copy the sign of the middle term and then 1. Plus, copy 4. Square root of y squared is equal to y. Copy the middle term and the square root of 4 is equal to 32 plus 16 plus 16 is equal to 64. So since the equation of an ellipse should equal to 1, then what we're going to do is that we're going to multiply, and we're going to divide rather 64 both sides. So it will be 64, 64, and 64. Then minus 1 squared. 64 divided by 16 is equal to 4. And y minus 2
problem. Since we have the standard equation, we can proceed in finding the A, B, and C units. The value of A squared here is 16, since this is the larger number of this equation. And the value of B squared here is 4. To find A is to just get the square root of A squared, and to find B is just to get the value of B squared. Square root of A squared is A, and square root of 16 is 4. And square root of B squared is B. Square root of 4 is 2. And now, in order to get the C units, we have to use the Pythagorean theorem, which is C equals square root of A squared minus B squared, and then substitute the value of B and A.